Good morning. I want to welcome you here for the orthophosphate test. Again, my name is Stu Hannum. I'm a teacher naturalist here at Riveredge Nature Center. We're standing in front of our farm pond here. I'm going to actually test a little bit of water in this farm pond here to show you how to do the phosphate test. A couple things I do want to say about the phosphate test before I get started with this is that of all the tests that you're going to do, in my humble opinion, I would say this is the most complicated. It is one that you need to be well organized. You need to follow directions carefully. There's a lot of onus that will be put on your teacher to make sure that they've got everything organized and that you know what you're doing. And with that said, when I would teach this with my students, if I had 12 lab groups doing it, we'd at least have one per class that had to repeat it because they messed something up, okay? So it is a little bit of a tricky test. It is one that it is, if we're gonna wear gloves, this is the one you're definitely gonna wanna wear gloves with. You wanna have some sort of eye protection. So I would never let students do this without eye protection because there definitely are some chemicals in here that can hurt your eyes. So we wanna make sure that chemical safety is practiced when you're doing this. All right. Why do we do a phosphate test? First of all, I want you to understand the phosphate test is that there's two kinds of phosphates, and this is where, if you've got a chemistry background, you'll understand a little bit more of what we're doing. If you don't, just believe me, okay? What I'm telling you is true, okay? There's organic and inorganic phosphates. The organic phosphates are the typical things. If you look out at this pond out here, you see all kinds of organic stuff that's in here. Every single leaf and thing you see here by winter time will be gone and dead, and it's going to make its way to the bottom of the pond, and it's got to be decomposed and broken down. Those are organics. So things like leaves are all natural things, branches, stuff like that we, every body of water has to deal with. It's just a part of being a body of water. But what we don't want to do is be adding human factors to that. And the human factors would be like sewage and things like that. And of course, our wastewater treatment plants go to great lengths to try to make sure that this stuff does not make its way into our river and body. And we want to make sure that that's not happening, and hence that's why we do this test. Where does organics come from? For those of you who might remember, if you remember your DNA, deoxyribonucleic acid, and if you remember that it's got that little chain, it's got those in the ladders, and in the ladders there's the phosphate groups that hold it together. Again, that's where phosphate is just an extremely important material in your body. It's something you need for your ribosomes, you need it for energy purposes. It's in life. Life's got to have it. Inorganic has more to do with like phosphate ions and different types of phosphoric acids that just happen because of their natural reactions in soils. That's where you oftentimes will pick it up. Humans will oftentimes end up adding stuff like this in either detergents, although most states now ban any detergents from having any phosphates in them. The other thing is fertilizers. Fertilizers commonly have phosphates in them. Again, you live in the state of Wisconsin. In the state of Wisconsin, they ban phosphates right now. They don't allow those to be in the water. They do cause a lot of problems in the waterway. They cause these incredible plant growths that you see out here. The bottom line is, people, is that plants love this stuff. It's what makes plants grow. So if you want plants to grow, there's two fundamental things you can do. Give them nitrates and give them phosphates, and they're going to grow. That's something that they want to have and absolutely will need. So it's something we want to measure. I do want you to understand, students and teachers, through the many years that I did this test, if I had 12 lab groups, 10 of them would come up with negative results. Just nothing in the water at all. And the reason, again, was a lot like the nitrates test. This is just something that if there's phosphates in the water, those critters are going to gobble it up. They're going to love it. That's something that they're going to want. So don't be surprised if you don't get a positive test here. I was oftentimes more surprised if we did get a positive test. As you can see, the chemicals we're going to use here are quite involved. I never did this test down at the river. I always did it back at my school in a lab because it was nice to be able to use Bunsen burners, okay, to do this. I'm going to demonstrate this without a Bunsen burner, but you'll kind of see what we're talking about. Okay, you are going to use what's called a square mixing bottle, okay, which you're going to have here. It is got volumes measured on it, okay, that you can check. We also have a small little flask that we're going to use. It's only 50 milliliters. It's a cute little flask. It'll grow up someday, but for now it's 50 milliliters, and it's going to work just fine. There's two chemicals here that you're going to use. Don't mix them up. If you mix these two chemicals up, what's going to end up happening then is your results aren't going to work, and you're going to have to come. In my case, my students had to come after school and do this, and that did not make them happy when they had to do that. There's a couple of chemicals you got to be really careful about. Sulfuric acid, okay, we're going to be working with. That is not something you want to get into your eyes. If you were to get it onto your hands or anything like that, just make sure you wash them off quickly. You don't need to panic or anything. It's not going to burn you instantly, but you do need to get it off your body. Same way with the sodium hydroxide. You need to get it off your body if you get it on there. We do have some demineralized water. You'll see why in just a minute that we're going to do there. This is the other container. If you mix up the order of any of these things that I do here, start over again. You're going to have to start all over again. You're not going to want to do that. All right, here's how the test works. It actually is a test that when my students would do it, we would struggle to get it done in 50 minutes. It's a longish test. I'm just going to show you the fundamentals of how it's going to happen. So first thing I'm going to do here is just get some sample of water here that I'm going to use to test with. What you want to do is take your sample of water that you have from the river, and you're going to pour it into this square mixing bottle. Now when you put it into the square mixing bottle like so, you need to get it to 20 milliliters, which is a little bit tricky to do. So you just carefully pour this in, reading the bottom of the meniscus, so you're at 20 milliliters. Okay, so you got that. Save that sample of water because you're going to want some more coming up in just a minute here. All right, then, since we don't heat things in stuff like this usually, what we're then going to do is we're going to take and we're going to put this into a 50 milliliter flask. And again, when you pour it in there, you're probably going to look and you're going to say, well, it doesn't say 20 on there. That's because these are really rough measurements. So don't be surprised if that happens. You know you have 20 milliliters because you measured it there. All right, now, with my students, when we would heat stuff, we would use boiling stones. I don't have any boiling stones here right now. If your teacher has some boiling stones, those are helpful to put in there when you do this. Okay, first thing that you're going to do is we are going to try to see if there's any organic phosphate in that water. The way we're going to find out if there's any organic in there is we're going to take this first pillow. This first pillow is called the potassium persulfate powder pillow. Okay? Don't confuse it with the second one. If you do, this test will not work. All right, you're going to have a little pack that looks like this. Give it one of these so that you can get this all mixed up in here as you go. It's got a nice little line for tearing, so you tear it. If you're working down at the river, again, it doesn't make any sense that this ends up being pollution. So put it in your pocket or somewhere so it doesn't end up in the river. All right, now you're going to take this little sample here and you're going to pour it into the 50 milliliter Erlenmeyer flask that has our sample in it. Okay? As soon as you do that, you're going to take this sample and you're going to go like this and you're just going to swirl it. It will not easily dissolve. It won't want to. So then what you do is you take our sulfuric acid. You're going to take the sulfuric acid. It is a child-proof cap, which means it's hard for everybody to open. You have to squeeze and pull at the same time. It's an unusual combination, but it's meant so that you don't have a child or something open this up. Okay, you're going to squeeze. I don't know if you're aware of this or not, but eyedroppers are designed that if you give them a complete squeeze and then release, you pick up exactly a milliliter. That's the way they're designed to be. So now you take a milliliter, drop it in, and you do a second milliliter and drop it in. Okay? Close the bottle. Be careful with this. If you get any on you, wash it off. Don't panic, but you do need to do that. Swirl this. Okay? Now, once you got this all swirled, then the next thing you're going to do is you're going to take this is if you're working outside. If I was working in a lab, then what I would do is I would use a Bunsen burner, my setup, ring stand, and all that other good stuff. I'd set this on here and I'd start heating this. If you're working in the field, this is what you use. You're going to have these little heat cubes. I used to always take these away from my students because they would just light them because they like to light them. Okay? You set these little bad boys down into here, like so. Put a match to it and they will light and they will burn. Okay? Then, and I'm not doing this because I don't have the time, but we'll let this burn. I set my flask on top and I boil this for 30 minutes. You boil it for 30 minutes. While you're boiling it, of course, water is going to come out of here. But what we're doing is we're converting the organic phosphates to inorganic, something I can measure. So now what I do is occasionally what I'm going to see is as this is heating is that it will get lower and lower in water because you're evaporating water. So occasionally you have to add demineralized water to get it back to 20 milliliters. Okay, get it close to that. If you are a student who forgets about this as you're heating it and goes off and starts socializing with one of your friends, as my students would do, they'll come back oftentimes and the water's gone and you got to start all over again. So don't do that. Keep adding water as you go. Keep this for 30 minutes. After 30 minutes, then what you need to do is use something that you can take this off of here. That flask is going to be hot. And so many of my students would grab this thing to take it off there, burn their fingers, drop this, and then they had to start all over again. So be really careful about that. That's going to be really hot. All right. Set that onto a surface that's safe so that you're not going to do any damage. And now what you're going to do is you're going to take and you're going to neutralize that acid you put in here. So we're going to take the sodium hydroxide. Again, squeeze and turn. Milliliter. 1, 2. That's neutralizing that acid. Okay. And now we should have our phosphate in there. Organic and inorganic. It's all been converted to inorganic. Now we go to our next powder pillows that are here. And this next powder pillow that you're going to use is what's called the Phosphor 3 powder pillow. So now you pull off the Phosphor 3. Again, you get one of these packets. Give it one of these so you mix the stuff up. Otherwise, it's not going to all come out of there. There's a nice little tear mark on here. Give it a little tear. Again, put that in your pocket so it doesn't end up being pollution. Take this little piece here. Dump it back in. Okay, like so. Put that away. Turn this. Now, I always thought this was kind of cool. When I would show my students in my class, we would spin this like so, and you can see all of a sudden, boom, it's starting to change colors. Kind of cool. It does it right in front of your eyes. Got to wait 2 minutes. You get a nice violet color. Okay? We wait 2 minutes. That'll allow me to go on to our next. Ooh, boy, this is really turning fast. Evidently, Mary Hollebeck here at Riveredge Nature Center has not got perfectly clean flask, or else we've got a lot of phosphates in our pond here, which is entirely possible. Okay? All right. We open up our black box. Inside our black box is a violet colored little wheel. Okay? We've seen this before. 2 test tubes. 1 test tube. Again, remember I told you to save a sample. We go back and we just fill it up to the top. Don't need to be careful at all. Put your sample top back on. Put it in the side of the wheel. It's got the color to it, the left-hand side. The purpose of that is to give a little bit of color background because all water has its own color background to it. All right, next thing we do. We then grab the other test tube, and what we do with this is we pour this in here until it fills the test tube with water. Completely filled to the top. Now notice mine went over a little bit. That's probably not going to happen to you because you'll have been heating yours, and if anything, you'll be a little low, and you might have to add a little distilled water to this. Be a little careful with this as you put the top on so you don't get it onto you because it is kind of a nasty brew. And you put this like so, and there's your color. You take your black box, you put this in the right side, and you spin your wheel until the color matches. You'll get a number. I came up with 35. All right, what does that mean? This is where you got to go into your book. And this is where teachers, you're going to have to give your students some help with this. Okay, if you get a nice reading, as we are in here, and I'm coming up with 35, you take the number 35 and you divide it by 50. So it's going to give you a number less than 1, okay, when you do that. Okay? That means that we were using a scale that was measuring phosphates that were from 0 to 1 milligrams per liter. Okay? That's the scale we were using. All right, if you do this, and this turns out to be too dark, which it can happen, Then look in your book, and there's an alternative method, and what that involves doing is you're going to have another method where you take and you pour some of this out to the white line, just measure this color, but now you don't divide by 50 anymore. There's a different mechanism. You divide by 10 rather than 50, and that changes that scale to an accuracy scale of 0 to 10, okay, milligrams. Check with your book, check with your teacher. They're going to help you with that. All right, once you get this reading and you get your milligrams per liter, then what you're going to do is you're going to read this scale back down here. Now, when you read this scale down here, here's the trick. You should get a number between 0 and 1, but look at the slope of that curve in there. To me, that's ripe for error. So you're going to do the best you can, come up with your number here, run a straight edge up here, see where it intersects with that curve, run it across, and get a grade. That's your Q value. You do it. Have your partner do it. Don't say anything to them. See what you get for a number, average those two numbers. That way, you each are having your own input. I thought it was this. I thought it was this. You're going to be hopefully a little more accurate as to the reading that you're going to get here. Oftentimes when my students did this, they got no color at all. Okay, if you get no color at all, that's a 0, and you get a grade of 100, and we all love hundreds. 100 is a perfect score. That's the best that the river could do. Okay. Now, this is the phosphate test. I think it's the 5th or 6th test that we do. I think it's the 6th test that we do in this series. As far as importance, it's not one of the most important tests, so you don't put a whole lot of weight on this test, but it does have some very important things environmentally to keep in mind about phosphates and why it's very important that we just be aware of phosphates going into our rivers and lakes. But we, in the state of Wisconsin, I feel, have done a really good job of trying to limit that stuff getting into our rivers, lakes, and streams so that we're not seeing as much of that. Okay? That's all I have to say about this today, and we'll see you at the next test.